try to ease into it with the easiest possible examples, and then we'll build up a little bit. We've done quite a bit the last few times. So let's start with the earlier stages of what we were doing. Let me just call this example 1, and let's say convert, just make up something, 0, 1, 0, 1 to decimal. Okay, that's a nice beginner example. And again, I'd like to give you guys some time to do these. Okay, let me write the questions down. I'll give you guys a few minutes to think about it, and then I'll do it. I know I can't give you time to do it, unfortunately, because only 1 hour, but you guys can start thinking about them at least. So that'll be 1. Let's make question 2, convert. Don't put too much of repetition here. Let's say convert 21 to binary. Okay. Question 3 will be convert. Try and be strategic here. Let's say 1, 0, 1 to decimal. I'll say where a simple sign bit is used. Sometimes my spelling gets a bit confused. That's how it is anyway. If I mess up, you guys can just tell me. Okay. Question 4, let's say convert. So we did that, we did that, we did that. Let's say convert. Okay, let's be strategic here. Minus 21 to binary. Okay, again, we'll say using simple sign bit. We'll say convert. Let me think which one is easier to do this. 1, 0, 1, 1, 0, 0, 1, 2. Not in binary, sorry, convert it to decimal. Using 2's complement. And 5 and 6, I'm not sure which one is easier. Let me just think, convert that to decimal. Then let's say convert to negative 21 again. Using 2's complement. Okay, so I think this should be enough to capture everything we've done in binary, well, calculation part of it at least. Okay, so I'm going to give you guys a moment to look at that. Yeah, just give you a moment. Think about it. And maybe if you guys can, in the comments, just tell me which ones of these seem difficult to you. Again, it's recap stuff, so it's been a while. If you guys forgot the stuff, it's okay. Even if it's all difficult, that's okay. No problem. Just make sure I wrote everything correctly here. Decimal, binary, decimal. Okay, it should be good. Let me just see what's happening in the comments. Okay, we got a vote for 5. Yeah, between 5 and 6, I'm not sure. One of them is a bit upsetting. It might be 5. Yeah. And we should remember rules for these things. Okay, so I probably won't remember all of them, but I have the notes open so we can go back to them as we need them. Oh, Jared, I see your comment now. Thanks, and same to you guys. Hope you had some kind of rest as well. Yeah, it's always a pleasure teaching you guys online. Much more engaging than when I'm teaching in person for some reason. All right, so let's start with number one. Maybe let's change color just for fun. Why not? So number one, convert this number to decimal. So for this, we just use expanded form, right? So we could write this again. We'll do it the slightly longer way. Recap of for everyone to see how we used to do this. So I'm just writing the digits of the number 0101. And this times 2 is a standard that I put in front of each binary digit. All right, so you'll see what I mean in a moment if you've forgotten it. Okay, taken the 0101 and put it here like 0101. And the times 2 is something which we always put in converting something from binary to decimal. Okay, and we do that because we want it to be an expanded form number. So we can start labeling the twos from the right, like this. This one on the extreme right is 2 to the 0. The next one is 2 to the 1. Then we got 2 squared. Then we got 2 to the 4. Sorry, 2 to the 3. I missed 3 somehow. 3 here. Yeah. So it goes in order from 0 going up until how many basically terms we have here. So 0, 1, 2, 3, that's all we have here. And essentially at this point, it's calculator work. You put this in the calculator and you'll get some number. That number is your answer, right? We could probably do this in our heads because we know that the first term here doesn't contribute anything. It's a 0. The middle term doesn't contribute anything as well. It's also a 0. All right, so what we squared plus 2 to the 0, which is 4 plus 1, which is 5. And remember, when you do these, you can always check them. We have ChatGPT and these things which we can just put the numbers in and ask it, convert to binary, convert to decimal. It will do it for you. So you can always check these. It's always good practice to check. It's a privilege we didn't have a couple years ago, but we have it today, so we must use it. Also, guys, if you are checking these things with ChatGPT, make sure you specify whether you're using things like simple sign, but two's complement, because answers change depending on those. Okay. All right, so number 2 says convert 21 to binary. I think I showed you guys 2 ways to do this. We will do the one which is quicker and easier because we like things that are quicker. Okay, so we start by writing the number 21. And of course, when you do this, have your calculators ready. Even if the numbers seem straightforward, it's always good to check in your calculator. Okay, why is this happening? This should be divided by 2. So let's see. If I take 20 divided by 2, it'll give me 10. So 21 divided by 2 is 10.5. Again, always check these in your calculator. Just be safe. So what was the thing here now? If it's 10.5, we write this as 10 with a remainder 1. Right? If we have any remainder at all, we write remainder 1. Okay, that was the rule we covered before. Again, guys, if you have questions, just interrupt me. It's okay. All right, so the new number is 10. So I do the same thing for the new number. 10 divided by 2 gives me 5. So 5 has no remainder, so it's 5 remainder 0. The new number is 5, so I'll write here 5 divided by 2, which gives me 2 comma 5. That is 2 with a remainder 1. Now, I know you guys probably can see that the remainders are not 1, but remember we mentioned that if there's any remainder at all, we just write remainder 1. So even 0.5, it becomes a remainder 1. Right? That's just how this thing works. Okay, so the next number now we're dealing with is 2. So I'll do this again. 2 divided by 2. That gives me just 1. And there's clearly no remainder here, so we write that as 1 remainder 0. Okay, the new number is 1. So 1 divided by 2 gives me 0, 0.5. 0, 0.5. That is 0 with a remainder 1. Now remember, once we hit 0, that's when we stop. All right, so we've hit 0 here, so we can stop. And I mean here, when we hit 0 here, then we stop. Okay, and we start reading our number from bottom to top. So this is the first number, this is the second one, this is the third one, and we read it as 1, 0, 1, 0, 1. So that is the answer. That is, what number did we convert? We converted 21 to binary. So this is 21 in binary, right? And remember, we can always check our answers by just quickly converting it back to decimal. Okay, we can do this the way we did it in question 1, or we can do a much quicker method, which is completely equivalent. The much quicker method, I'm going to write here, check. The quicker method will be to write this as, I'll just write you 2 to the 0. That represents this first string, or this first bit here. 2 to the 1 would be here, but it doesn't exist because there's a 0 there. So this exists. 2 squared is here. Then 2 cubed would be here, but it doesn't exist. Then 2 to the 4 is here. 2 to the 4. So just add these up, and you should get back to the original answer. If you do, that means we did the right thing. Okay, so what's 2 to the 4? I'm pretty sure it's 16. Yeah, 16. 2 squared is 4, and then we got 1 here. 16, 17, 18, 19, 20, 21. Okay, so that works out. So our check reveals that our answer was correct, so we're happy with this right here. Okay. Also, it's from, let's see, let me just read the question again. Convert to binary. So it didn't tell us anything about the number of bits we need at the end, which is okay. So you'll get full marks for something like this, but it's always good in general to write these using 8 bits if you're not told anything else. So this is now 1, 2, 3, 4, 5. 5 bits. So let me rewrite the answer. 10101. That's 5 bits. If I want to make it 8 bits, I'll just add zeros to the front until they are 8 bits. So that's 5 bits, 6, 7, 8. Right, so this is completely equivalent to the answer on the left, except now this uses 8 bits. So it's good to use a standard number of bits, right? That helps us, especially when writing negative numbers and stuff like that. So this is probably the way to go. If you did it this way, it's also fine, but just be safer and let's go with the method on the right. 8 bits. Let's always stick to 8 bits. Okay, so that was number 2. Number 3 says convert 1101 to decimal, where a simple sign bit is used. Okay. So remember, simple sign bit means that the first bit, so what is the number? 1101. 1101. A simple sign bit means that this here represents the magnitude of the number, and this here represents the sign. So a 1 means negative, a 0 means positive. So all we need to do is convert 101 to decimal. That we can do very quickly. I'll do this using the shorter method. So I'll write 2 to the 0 at the bottom, because that's the first one. The next one gives me 2 to the 1, but that doesn't exist because the bit is 0. Then 2 squared is the next one that exists. So I write that down. Add these two together, you get 4 plus 1, which is 5. Okay, and because the sign bit is a 1, that means the answer is negative. So this here is equivalent to negative 5. That's the answer. Yeah, that's using simple sign bit. A simple sign bit is the most straightforward way to represent a negative number. Okay. Next question is convert negative 21 to binary using a simple sign bit. Okay. So let's just see, what do we do for this? We just basically convert 21 to binary, which we've done already in question 2. And for this, it's important that we use a standard of 8 bits. So get an 8-bit number which represents 21, and then make the first bit a 1. That makes it negative 21. All right, so number 4 is straightforward. We just need to copy a bit of what we've done before. So we want negative 21 in binary. So we'll start off by writing 21 in binary, which we've done above here somewhere. Yeah, it's this one here, the one with 8 bits. So it's 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1. That's 21. So now you can imagine that negative 21 is simply going to be the same thing, but now the first bit is a 1. That's the only thing that changes. So that's negative 21 using a simple sign bit. All right, important that we remember these words because it's different there's different methods to represent negative numbers. Okay, let me just check the chat quickly if anyone is saying anything to me. Yeah, Alison, no stress. That is a bit of a confusion. So I'm going to do them separately. So far we've only done simple sign, but two's complement is a bit more complicated. So simple sign, but just to be clear, simple sign, but only uses the first bit to represent the sign of the number. Just like here, this is a perfect example. Right? If the first bit is a 0, let's change color for this. If the first bit is a 0, it means it's a positive number. If the first bit is a 1, it's a negative number. All the other bits just represent the number itself. The first bit is only the sign. Okay, that's why they call this a simple sign bit, because it's just one bit. That's the only thing that changes for positive and negative numbers. And this is actually why it's important. This is quite important. This is why we use a standard of 8 bits, because we've seen here that 21 can be represented using 5 bits. See right here above here? Here, right? This is 21 using 5 bits. The first bit here is a 1, but that doesn't mean it's a negative number, right? And that can get confusing. That's why we use 8 bits instead. Because with 8 bits, we're adding leading zeros, right? We're adding leading zeros here. So here it becomes clear those zeros don't have any, they're not necessary for the number. They're just there as placeholders to make 8 bits. So then it means the last bit is not really used. It's just a placeholder. So that's why we can give it a new purpose. So that's why for simple sign bit, it's important to use extra bits, right? Like here, we're using 8 bits. So 8 bits is a good number to stick with unless they tell you otherwise. Okay, the standard is usually 8, 16, 32, but 16 and 32 are massive, so 8 is usually good. Okay. All right, again, guys, if I lose anybody, just stop me. So what was number 5? This was the, yeah, convert this to decimal using 2's complement. Okay. Now I need to try and remember 2's complement myself. Let's write the number down firstly and let's see what we can do with it. So it's 1101. 1101, and my memory is pathetic, so I have to go back. 1001. Okay, so how do we convert? Let me just think. Maybe 6 is easier. Let's pull up the rules. Right, we got the rules. Let's use them. Converting 2's complement binary number to decimal. Is this the more complicated one? Yes, it is. But anyway, let's do it since we're here. Let's look at the rules, not the actual thing. So the first thing is to subtract 1 from the number. Okay, and this is going to be, maybe we should do 6 first, just to build up to it, right? Because 6 is a bit easier. Let's do 6 first. Okay, so now it's kind of coming back to me what this actually is. 6 is to get us an idea of how 2's complement works, firstly. There we go. So convert negative 21 to binary using 2's complement. Let's do that first. Negative 21, and this I think was a 3-step method. So I think I remember them, but let's just be sure and go to the rules here. 2's complement. Here we go, 3-step method. So the first step is to convert the number to binary, basically assuming it's a positive number. So that's step 1. Convert the number to binary, assuming it's positive. So step 1 would be to convert 21 to binary. Maybe let's write here step 1. Let's just keep track of what we're doing. Step 1, convert 21 to binary. So we've done that already. Directly above us, it's 000101101. See here as well, I'm using 8 bits, standard of 8 bits, just to be safe. Although we could do it with 5, let's rather use 8. So step 1 is to convert the positive version of the number to binary. Step 2 is to invert all the digits. So that invert all the digits just means ones become zeros and zeros become ones. So I'll write this as 1, 1, 1, 0, 1, 0, 1, 0. Right, and I'm pretty sure I remember step 3, but let's just check. Yes, it's to add 1 to the result. Okay, so again, I might have shown you guys more than one method to do this. So this is an easy one to do. We can just do it by looking at it, but I'm going to show you the other method as well. So adding 1 to this number, I'll write it like this: 1, 1, 1, 0, 1, 0, 1, 0, plus a binary 1 would look like 1, but we want it to be an 8-bit binary number. So 1, 2, 3, 4, 5, 6, 7 zeros with the binary 1. And the answer to this is going to be exactly the same, well, almost exactly the same as the original number, except a 1 at the end instead of a 0. Right? If you can count in binary, if you can see that intuitively, it's good. Don't stress, we will use a method which works all the time. Again, what we're trying to do here is just add 1 to this number right here. Just add 1 to that number. So we'll do this in the old-fashioned method of adding the way we used to do in high school, maybe primary school, I'm not sure, but anyway. So what I'll write here is 1, 1, 1, 0, 1, 0, 1, 0, right? And add that, we're adding 1 to this, right? So I'm going to write 1 at the bottom of it here, a binary 1. Now you guys may remember there's only there's only 4 possible things that can happen in these, right? So should I write? Yeah, let me just write it as a recap. You could get a 0 plus a 0, which will just give you 0. You could get a 0 plus a 1, which is 1. You could get a 1 plus a 1, which is 10 in binary. It's not 2 because there is no 2. And you could, in the rarer cases, get 1 plus 1 plus 1, which is 10 plus 1, which gives us 11. So these are the only 4 possible things that can happen when we're doing sums like the one I wrote on the left. Okay, let's see what happens. So we'll just keep those rules in the back of our mind. So I start from the extreme right. Here we have a 0 plus a 1, right? That just gives us 1. According to the rules on the right, 0 plus 1 is 1. And the next one is 1 plus 0 is the same as 0 plus 1. The order doesn't matter. So 1 plus 0 is just 1. Then we've got 0 plus 0 is 0. 1 plus 0 is 1. And so on. The rest are easy to fill out. And we see it gives us the same answer that I worked out at the top using intuition. Right, so that is our answer. This what we worked out at the bottom is our answer. So yeah, we can say that that is negative 21 in binary using 2's complement. Okay. So yeah, it was good to do this one first before getting back to number 5, because number 5 is essentially about reversing 2's complement, I think. Let me just check again. Yes, okay. So now we can do number 5. If no one says anything, I assume we are all okay. Or at very least, we know this is on video, so we can go back and check it over and over again. So let me see if I can remember this number in one go. Shouldn't be too difficult. 1101, and the other, I'll use the visual part of my brain to remember that. 1101, 1001. I have to use tricks because my memory is pathetic. Okay, so now converting this into decimal, assuming this is a 2's complement binary number. Converting to decimal, we have a 4-step method, which we'd rather check instead of me trying to stumble around and memorize these things. Here we go, 4-step method. So first subtract 1 from the number. This already gets a bit tricky. Step 1 is already a little bit of a nuisance. So subtracting 1, so let's write it here. Step 1, subtract 1. So 1, 1, 0, 1, 1, 0, 0, 1. I'm going to write here minus 1. I don't know why I put the bracket there. Let me just write immediately a binary 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, but now we haven't learned how to subtract in binary. We only know how to add in binary. right? And also, because we're dealing with 2's complement, we can't just subtract, we need to subtract. Okay, let me say it like this before I stumble around too much. We are subtracting 1, so maybe that's why I wrote the bracket. We're subtracting 1, but we only know how to add in binary, right? So we need to essentially add a -1, right? We know how to add in binary, and we know how to represent negative numbers. So now we need to represent -1 so we can do this addition, right? Addition, I say in quotes, because that's how we're going to subtract. And then we need to know what -1 looks like. And because we're dealing with 2's complement, it has to be a 2's complement -1, right? It can't be a simple sign bit -1. So let me just write this here with exclamation to say this is not what we do. 1, 2, 3, 4, 5, 6, 7, 8. So this is a simple sign bit -1. This is not the one we want. We want a 2's complement -1. So how do we actually represent that? Well, we have to use the 3-step method to convert -1 into a 2's complement binary number. This is becoming a disaster, but this is unfortunately the way to do it. We have to do this only once, and then we can remember what -1 looks like, and we can keep on reusing it, but we have to check what it looks like first. Okay, so what does it look like? We have to use a 3-step method to convert -1 to binary using 2's complement. One of the method. Maybe we should change color now. So step 1 was to just convert the number 1 to binary. And that is easy. It's just 1, 2, 3, 4, 5, 6, 7, 8. All right, step 2 was to invert all the digits. So that will be 1, 1, 1, 1, 1, 1, 1, 0. And step 3 was to add 1 to this. 1, 1, 1, 1, 7, and 0 plus a binary 1, which is 1, 2, 3, 4, 5, 6, 7. And that's a straightforward one to work out. It's 1, 2, 3, 4, 5, 6, 7, 8. It's just all ones. Okay, again, we can do this addition using the longer method, which I showed you above. And if you do that, you'll find that you just get this. So this is the result we need. This is -1 in 2's complement binary. Okay, so I'm going to bring that back here to our step 1 for converting a 2's complement binary number back to decimal. So I can see why this would confuse people. But anyway, it's good that it's on video. Okay, so let me do it like this. This is our original number, 110110001. We now need to add to this the number we just worked out, which is -1. 1, 2, 3, 4, 5, 6, 7 is just 7 ones. Okay, so this we can do now. We can do this using the method of addition that we have learned. So I'll do this at the bottom here, 110110001. We're adding that to 1111111. Now remember, all of this is just to fulfill step 1, which is to say subtract 1 from the number. This is how we subtract 1 in 2's complement binary. Just remember, all this roundabout, everything that we've done is simply to subtract 1. So it may look complicated, but remember, in principle, what we're doing is easy. Just subtracting 1. Okay. So let's add these two numbers together and see what we get. On the extreme right here, we get 1 plus 1, which according to our rules above, we wrote them somewhere. There's it here. According to those rules, 1 plus 1 gives us 10. So that's going to be 0, but we have to carry 1, right? Just like the old-fashioned method of adding. We've carried a 1. Now the second row here is going to give us 1 plus 0 plus 1. That's essentially 1 plus 1, right? That's another 10. So there's also a 0, carry a 1. That gives us another 10, so that's a 0, carry a 1. Now we've got 3 ones, which gives us 11. Again, according to the rules above here, all of these are summarized. This is the last one at the bottom. 1 plus 1 plus 1 gives us 11. So we use that down here. 1, 1, 1 gives us 11. So that's 1, carry 1. We have another 3 ones, which is 11. 1, carry 1. 2 ones gives us 10. So 0, carry 1. 3 ones is 11. 1, carry 1. Now we have another 3 ones, but there's no place to carry anything. So we just write the final 11 here at the bottom. And this leads us to our first, I'm not sure if we've done this already, but our first kind of new thing, which is if we end up with an answer which is longer than 8 bits, right? Because we're dealing with 8-bit binary numbers, the answer at the bottom is 9 bits. So we just simply cut off the last bit, and we don't consider that to be a part of our answer. Okay, so having done that, the final answer is, not the final answer, the answer to step 1 is 110110000. Okay, all that just happened there. All that to just do step 1. All we've done is just subtract 1 from the original number. That was step 1. Okay. And I think that's the hardest step. I'm afraid to look at step 2, but let's check what it is. Invert all the digits. Okay, that we can do. That's straightforward. Where's all this extra stuff coming from? Step 2, invert all the digits. So just zeros become ones and ones become zeros. That's all it is. All right, step 3. Where are you? Convert the resulting binary number to decimal. We can convert it to decimal, that we know how to do. We should be experts at that by this point. Okay, so I'm going to write this. 2 to the 0, 2 to the 1, 2 squared. Those are the first 3 digits. The next one is 2 cubed doesn't exist. 2 to the 4 doesn't exist. 2 to the 5 does exist. Everything else are all zeros, so they don't matter. So plus, plus, plus. I'm pretty sure 2 to the 5 is 32, but let me just double check it. 2 to the 5 gives us 32 plus 4 plus 1. No, that's not 1, sorry, that's 2. 32 plus 4 plus 2 plus 1. So that's 36, 37, 38, 39. All right, so that's step 2. That's step 3, sorry. I think that was step 3, right? Yeah, that was step 3. So I just didn't write step 3 for some reason. Let's put it in here. Step 3 was to convert the inverted digit binary number into a decimal number. And step 4 is a nice straightforward step. We can do that one. It's to add a minus sign. So if in step 3 I got 39, step 4 we must just get negative 39. So simply include a negative sign in front of your number. Okay. So even though this is complicated, the good thing about that we always follow that always works. And I've done one example here, which is recorded. So all the stuff here, especially the stuff in blue, is a bit messy, but it's something that, you'll get used to it with a bit of practice. Okay, and is that it? That's the end of our questions so far, which is good, because now we can get on to the slightly new stuff. Okay, but before I do that, let me just check if there are any questions. If you guys want to unmute and ask, you're welcome to do that. Otherwise, let me just check the chat. Let's see what's happening. Okay. Yeah.
Hi, sir. I got a question.
Yes, how can I help?
On step 3, it says 2 to the power 0. How did you get 1? What's the rule behind it?
2 to the power 0. So that's just exponential rules. Any number to the power 0 just gives you 1. Yeah.
Okay,
Is that the
thanks.
question? Yeah. Okay, no worries. All right. Yes, let me just think for a second whether I should have options here now. We're done with all this stuff. So again, there's more examples for you guys to try. And again, luckily we can always check these things with ChatGPT, right? It's always very easy to check these. So I think we spoke about this table the last time. Yeah, so this is stuff we need to do. And maybe sometimes they make too many subcategories here. So maybe I should just make some examples that covers all of these. These examples are usually more helpful, I think. So let's change color and formulate another few questions to cover all of these things. So let's say complete the following. I guess there'll be a bit of recap here as well. So let's say one will be, think of a nice number. Let's say something like 5 plus 9. Okay, maybe I should say complete the following, use 2's complement if necessary. All right, so 1 will be 5 plus 9. 2 can be, let's make this 9 minus 5. 3, let's say 5 minus 9. Okay, maybe I should add a layer to this and say check your answer. Okay, once we're done with this question, this is like every possible thing I can imagine they could ask you, including what we've done above. So this is good stuff to make sure we know how to do. Complete the following. I don't know if it's understood here, but let's say in binary. Right? In case it's not understood, that's what I mean. Complete these in binary because obviously in decimal we can do these easily. Right? So let's get going with number 1. You guys can probably guess how to do this using the addition method we've done above, but let me go through it anyway. And time flies in these lectures. I don't even know how an hour is almost done already. Okay, 5 plus 9. So we know 5 plus 9 is going to give us 14, right? So what we get at the end should be the binary version of 14. So let's first convert 5 and 9 to binary. Okay, again, you guys can use the method that you're comfortable with here. But for me, sometimes you can spot these like this. If I look at 5, I immediately recognize that 5 can be written as 4 plus 1. I say 4 plus 1 because these are both base 2 numbers. Right, this is 2 squared plus 2 to the 0. And that means I can write this as 1 times 2 squared. And then all these things in between don't exist. So what I mean is 0 times 2 to the 1, because 2 to the 1 is not here. And 1 times 2 to the 0, because 2 to the 0 is here. Again, guys, if this confuses you, don't worry about it. It's just helpful sometimes if you can spot these and shorten your calculations. But if it's not working for you, just use the method of, take 5, divide by 2, get something with a remainder or with no remainder, what I did above. Okay, so what I'm just doing here is if you can spot it. All right, now the reason I wrote this is because this is basically the number in expanded form in binary. And then I can just extract the binary bits from the front here, which is 1, 0, 1, right? 1, 0, 1. So that is the number in binary. But we want it, of course, using 8 bits as always. So I'll write it as 1, 0, 1. That's 3 bits. 4, 5, 6, 7, 8. So that is the answer we want. That is 5 in binary. Okay, so we also need 9 in binary. And I guess I picked 9 because it's also easy to spot this with 9. You can write 9. Let me just write here, that's 5. You can write 9 as 8 plus 1. And these are also base 2 numbers. So as long as you can write it as the sum of base two numbers, then we're good. We can convert them quickly. So this is 2 cubed plus 2 to the 1. Is that right? Yeah. And write this in expanded form. So this is 1 times 2 cubed. All right. 2 squared doesn't exist. So we'll write 0 times 2 squared. Something gone wrong here. Oh, sorry. This is 2 to the 0, right? That should be a 0, not a 1. Sorry. 2 to the 0 gives us 1. Yeah. Okay. So now we're fine. So as I was saying, 2 cubed exists, so it gets a 1 in front of it. 2 squared is not here, so that gets a 0. 2 to the 1 is not here, so it gets a 0. 2 to the 0 is here, so it gets a 1. So then we immediately can extract the binary bits from this expanded form, which is 1001. 1001. And now using 8 bits, we'll write this as 1001. That's 4, 5, 6, 7, 8. So let's just keep these labels so we know this is, okay, let's write it like this with an arrow instead. This is 5 in binary. This is 9 in binary. And let's keep that because we're going to use that a few times. All right, so now can we add these two numbers together? Question 1 said add 5 and 9, if I remember correctly. Yeah. And let's see if we end up getting the binary version of 14. So let's take the 5, which is 1, 2, 3, 4, 5, 1, 0, 1. And then we get 0, 0, 0, 0, 1, 0, 0, 1. That's 9. Add these together using the rules we learned above. 1 and 1 is 10. That's 0 carry 1. 1 and 2 zeros is just 1. 1 and 0 is 1. 0 and 1 is 1. And the rest are just zeros. So this is the answer. Is this the binary version of 14? I really hope so. If it's not, we don't have time to correct it. So let's hope it is. So let's check this quickly. This is going to be 2 to the 0 is not there. 2 to the 1 is there. 2 squared is there. 2 cubed is there. And this is looking good already. So this is going to be 8 plus 4 plus 1. Oh, something wrong here. 8, 9, and give us 13.
8 plus 4 plus 2.
Plus 2. Oh, thank you. Okay, there we go. Thank you. I don't have to check who that is. I'm sure that's Allison correcting me. Thank you very much. So 14. Perfect. All right, then we're good. So number 1 is good. Now I made these such that I don't have to rework out everything. Number 2, we already know what a binary 9 is, so we don't have to rework that out. So number 2 says 9 minus 5. We know what 9 is. Let's summarize our information here quickly. 9 is 0, 0, 0, 0, 1, 0, 0, 1. Minus 5 in 2's complement. Oh, we need to work this out now in 2's complement. So minus 5, it was a 3-step thing, I think, to convert minus 5 using 2's complement. So I'm just going to write here. Step 1 is to convert 5 to 2's complement. What was that? It was here somewhere. 101. Okay, 101. That's 3, 4, 5, 6, 7, 8. Okay. Step 2 was to, what was it? Invert all the digits. Yeah. So 1, 1, 1, 1, 1, 0, 1, 0. And step 3 was to add 1 to this number. Okay, so again, we can do this the long method, but I'm going to do it the quick method just to save some time. This will just be a 1. So this is minus 5 in 2's complement binary. Okay, now why does it do that? All right, so now 9 minus 5 is just going to be 9 plus this number I just worked out, right? 9 plus minus 5. So let's bring this here. 9 minus 5 is equal to 9 plus minus 5, which is, let's write the 9 on top, 0, 0, 0, 0, 1, 0, 0, 1. Right, the -5 at the bottom, 1, 1, 1, 1, 1. No, that's a 0. 0, 1, 1, 6, 7, 8. Okay, that's fine. Add these together and we should get a decimal. Let me just think. We're going to get a positive number. Okay, so that's good. So we should get a positive 4. All right, panic there for a little bit. 1 and 1 here gives us 10, 0 and 1. 1 and 1 gives us 10, so 0 carry 1. That's just 1. 1 and 1 is 10, 0 carry 1. Another 10, 0 carry 1, 0 carry 1, 0 carry 1, and the last 10 is just a 10. We cut off that extra bit, and this here is our answer. Okay, so we should get 4. It's looking promising. Let's check it quickly. Check. 2 to the 0 doesn't exist. 2 to the 1 doesn't exist. 2 squared is the only one that exists, which gives us 4. So we're perfect. So that works out. 9 minus 5, we're good. That was number 2. Okay, number 3 might take a bit of effort, but we have 9 minutes, so I'm sure we can get through it. 5 minus 9. Okay, number 3 is 5 minus 9. Let's just take stock of what we have. Do we have a 5? We have a 5 somewhere. Yeah, it's 101. That's 3, 4, 5, 6, 7, 8. We don't need a 9 immediately, but let's just keep stock because we're probably going to need it at some point. 9 is 1001. That's 4, 5, 6, 7, 8. Okay, so now we need a -9. So again, we use our method, 2's complement, to convert -9 to binary. It's a 3-step thing. Step 1 would be 9 in binary, which we have above. 1, 2, 3, 4, 1, 0, 0, 1. Step 2 is to invert all the digits. So 1, 1, 1, 1, 0, 1, 1, 0. Step 3 is to add 1 to this. Again, this is a straightforward one. You can use the longer method if you need to, but for time, I'm just going to do it in one go. So this is -9 in 2's complement binary. Okay, so 5 minus 9 is the same as 5 plus -9. So we'll take our 5, which we've written above, 0, 0, 0, 0, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Fine. And we add that to -9, which just worked out. It's 1, 1, 1, 1, 0, 1, 1, 1. Add these together. Let's see what we get. I'll try and do this a bit quickly. We've got a bit more to do. So 1 and 1 is 10. That's 0 and 1. Another 10, 0 and 1. 3 ones is 11 in binary, so that's 1 carry 1. That's just a 1, and the rest just give us 1s. That seems a bit strange, doesn't it? But maybe that's okay, because remember now, 5 minus 9 is going to give us -4. Let's just keep that aside here, -4, and we've worked in 2's complement binary. So this answer we get at the bottom here should be a 2's complement binary -4. Now, how do we check that? We can't just convert it back the way we normally do. We have to use that 4-step method to convert it back because it's a 2's complement number. So this one's a bit of a nightmare, but if we convert this back, we should get -4. So let's do that. Maybe let's change color to note that we're doing something a bit different here, a bit strange. But yeah, again, this is how we do this. So step 1 in converting this back to decimal would be, God only knows, I don't remember. Where is it? Is this it? Yeah, this is it. So subtract 1 from the number. Okay, so that's the thing. Subtract 1. So to subtract 1, we add -1, right? So I'll write the original number here. 1, 2, 3, 4, 5, 6, 7, 8. And we're subtracting a binary -1. That's what it looked like. We worked it out already at some point. That's the 2's complement binary -1. So this is how we subtract 1. So 0 and 1 is 1, 0 and 1 is 1. These are all going to be 10s. So that's a 0 carry 1. Actually, now that's 11. That's a 1 carry 1, another 11, 1 carry 1, 11, 1 carry 1, 1 carry 1, and the last 11 is here. We cut off the last bit, and what we have here is the answer to step 1. I'm sure step 2 was to invert all the digits, but let's just make sure. Why can't I see anything? Invert the digits, all right. So invert the digits, we get 0, 0, 0, 0, 0, 1, 0, 0. Step 3 was to do something. This is where my brain stops working. Guys, I think someone's mic is unmuted. Convert the resulting binary number to decimal and then add a minus sign. Convert this to decimal, so that's going to be, okay, it's looking promising. That's going to be 2 to the power 2, which is 4. And step 4 is to add a minus sign in front of it. So that gives us -4. So that means what we have above here is -4, which is exactly what we wanted. Thank goodness it worked out, because I don't think we have time to do that again. All right. So that's everything I wanted to cover. Everything before the theory part, because you guys can read the theory on your own if we don't finish it. And then the next time I see you guys, we can probably get going with learning unit 5, which is the last one, and it's quite a short one as well. Okay, but before I get ahead of myself, let me just see if there are any questions or anything you want me to go over again. Comments, complaints, anything at all. I'll open the comments in the meantime. Let's see. Yes, always use calculators. Always be safe. Okay. Uh, couldn't have said that better myself, Ellison. Yeah. Okay. Yeah, that's the only trick, really. And just practice a few and you'll get used to that. Okay, so let's also take a sneak peek at what happened in the notes where we got to. We've gotten through all the stuff here. Again, there's many examples for you guys to go through as you get through everything here. At 205 and 15, there's a nice one, similar to what we've done. The next few things we will do is theory. Maybe not though. Maybe let's save this for the end, because you guys can't read this by yourselves. Probably the next time I see you guys, I'll start with learning unit 5. And let me just show you what we will go over so that you can prep a little bit if you want to. So you guys may remember these truth conditions. This is stuff that we've done before in learning unit 3. And it would be helpful if you guys can recap this a little bit before we get to the next lesson. That will help you guys a lot, because I'm going to use these in these things called truth tables. So this is what we will do the next time. This is learning unit 5. And once we're done with these truth tables, there's probably a little bit more stuff to do regarding proofs, but it's mostly truth table stuff, even the proofs. After that, we can go over a little bit of theory. That should all be able to happen within 1 or 2 sessions. And I think we still have, if I'm not mistaken, at least 3 sessions. So that leaves at least 1 for revision and general questions and comments. Okay, so I think we're in a good place. We're doing well so far. And we can actually finish on time, which is a good thing. All right, so guys, I'm going to be here for another 5 minutes or so. If you have questions, you're welcome to stay and ask. Otherwise, I appreciate your attention. Thanks for sticking with me through all this nonsense. And yeah, take care, guys. Have a good one. My pleasure, guys.